All right, so we are moving on. We've got a very short section here. And then we'll do another, I mean, really, we're not that far. This is not normal. Usually units go a little longer. This is going to be a pretty short one, probably 2 weeks at the most. Okay, so we've got 4 sections. I mean, 2 weeks until we'll do like another test. And then we get a little longer section after that. So we're going to look at initially, today we're just going to do a brief review. This will be kind of lightweight. We're just going to review how to write and solve inequalities, linear inequalities. Tomorrow we'll look at compound inequalities. I'll give you a work day, and then we'll jump back in and we'll look at how to solve absolute value equations and inequalities. And that's it. It's pretty short. So today, solving linear inequalities. What do we know about inequalities? Let's kind of just do a little review here. So we know inequalities are really just very similar to equations, only they use different symbols. Instead of an equal sign, we'd use those 4 symbols, right? Either something, less than, greater than, less than or equal to, or greater than or equal to. And here's just quick examples of, of 4 different inequalities using those symbols. You guys have all seen this stuff before. This is from our book. I'll throw this in there. This isn't really that big a deal. A linear inequality in one variable. So we're only using like only x's, only y, something like that. Just means it's some inequality that could be written in this form if I collected like terms. And anyway, that's really not that big a deal. We'll skip through that. Okay, let's get down to business here. So when we want to graph inequalities or write inequalities, there's really 2 different ways that we're going to write these using regular inequalities, which we'll call inequality notation, where we actually write inequality symbols down. And then I'll show you another one called interval notation, which is really handy. Okay? So if we are using, when we're doing graphs of inequalities, like if I wanted to graph something like a is less than -1, or x is greater than or equal to 8 on a number line, we always have to have an endpoint, right, if we're graphing an inequality, which we write as a dot normally. If we're including the equal signs with our inequality, what kind of an endpoint or a dot do we use? Say it again. It's closed. Yes, very good. It's closed. Okay, meaning it's going to be solid, right? It's not an open one would be where you have like an outline with an empty middle. This one is a solid dot. And then if we're using inequalities with no equal signs, what would it be? Open, yeah. So interval notation is another way of writing this. Like, let's go ahead and do a couple, like let's do 2 examples real quick. You guys tell me, if I wanted to graph the inequality where a is our variable, a is less than -1. On my number line, what's really the only number I would need to write on my number line? -1, yeah. So if we write -1, what's that going to look like if I want to graph a is less than -1? Okay, I'm going to draw an open endpoint. And then my graph is going to extend to the left or the right. Everybody just point with your fingers. Which way is it going to? Yeah, right. Less than means left of, right? They both start with L. That's easy. So it looks like that. Okay. How about this guy over here? If we wanted to graph x is greater than or equal to 8, I'm going to need 8 on my graph, right? That's the number I'm focusing on. How would I graph that inequality? Closed endpoint, and I'm going to the right. Okay, good. So we've got these inequalities that we've now graphed, right? Okay, I want to show you another way of writing these inequalities called interval notation. And interval notation really just goes with the graph. It matches the graph exactly. So how do we do interval notation? Interval notation, it's short and easy, very handy. It uses 3 ingredients. It uses infinity symbols, either negative infinity or positive infinity. It uses parentheses and brackets and then a comma. And that's it. That's all the ingredients for interval notation. And here's what it looks like. So these are the kinds of symbols, negative infinity, positive infinity, parentheses and brackets. And here's how we set it up. we're always going to write a comma in the middle with interval notation, and we just write two numbers, or the numbers, or we might use infinities instead. Whatever the left endpoint of our interval is goes to the left of the comma, and the right endpoint goes to the right. Okay, so let's try this guy over here, this blue one. I'm going to put my comma in the middle. Let's start with the right. What's the right endpoint of the interval that we graphed? Everybody agree it's -1? The ant can walk to the right on that solution, that blue solution of our inequality that we graphed, until the ant gets up to -1, and that's the end of the line, right? So that's our right endpoint. Now notice how we deal with endpoints here. We're going to include a parenthesis if it's an open endpoint, and a bracket if it's a closed endpoint. So what would go with the -1 here? A parenthesis or a bracket? Is it an open or a closed endpoint? It's open, so I would have to do that. Okay? So next to it, I'm going to enclose it in a parenthesis, which means we don't include the endpoint. Okay, now this is a little bit strange, but what is my left endpoint going to be? -infinity, because look, that arrow indicates that it just goes forever to the left. Now, so you got to be a little bit careful with this. I mean, it all makes sense. I think intuitively you guys were all probably thinking, okay, it goes forever, that's going to be like a -infinity. But keep in mind that -infinity or positive infinity, those are not numbers. You could never actually get there, right? So when we say something like -infinity, we don't really actually mean that's an endpoint. It just means that there is no endpoint. It just goes forever to the left. Now I want you to think about this here. If I'm using an infinity in interval notation, think about what kind of enclosure we would have to use. Would I include a parenthesis or a bracket? And let me ask you a leading question here that'll kind of give the answer away. If the ant is walking to the left, could he ever actually get to -infinity? So then it really wouldn't make sense for me to use a bracket, would it? Right? Because a bracket would mean that the ant could stand on the endpoint, which he can't. So what am I going to use always with an infinity? I'm going to always include and parentheses is plural. Singular is parenthesis. Not that that's that big a deal, but if I'm talking about a single one, I would call it a parenthesis. And so I would have to include a parenthesis to the left because I've got an infinity symbol. Okay, give me thumbs on that. That make sense? Okay, what about this? And so that's the interval notation corresponding to the inequality A is less than -1. Interval notation matches up really well with the graph. Right? It's kind of a visual way of writing that inequality without actually graphing it. Okay, what about the red one? How am I going to write this one using this new interval notation? I got my comma. What's going to go on the left? 8, yeah. With what kind of enclosure? Bracket, yes, right. Because it's closed, right? Bracket goes with closed. What goes on the right? Infinity. With parenthesis. There you go. Okay, very good. Very good. So something that might be kind of helpful, I'll give you a little way of remembering things here. All the things that require more ink to draw go together, right? Inequalities that include an equal sign, it takes a little bit of extra ink to draw the equal sign compared to not drawing it, right? Takes a little bit of extra ink to fill in the endpoint to make it closed, and it takes a little bit of extra ink to make a bracket compared to a parenthesis, right? So all the things that take more ink, they go together. The things that take a little bit less ink, they go together. Okay? Make sense? All right, so how about then solving inequalities? If we're doing algebra, which we're going to do a little bit of that today. So follow the same rules to solve an inequality as you do to solve an equation, but what do we have to do to the inequality symbol if we multiply or divide both sides of our inequality by a negative number? We got to flip it, don't we? Yeah, good. So you guys are remembering this stuff. That's good. All right. Real quick, just a reminder here. We actually have three types of notation we could use. We're not really going to use set builder notation. We're just going to use inequality notation and interval notation, right? So I just want you to see that these two things go together. They mean exactly the same thing. They're just different notations, okay? All right, so let's try one of these. Let's solve this inequality, and then we're going to write our solution using both kinds of notation, and we're going to graph the interval, okay? Graph the solution. So what am I going to do first here? Now, if you're getting, if it seems like intimidating that there's an inequality symbol there instead of an equal sign, don't let it bug you. We're going to treat this exactly the same as an equation with that one exception, which is the rule you guys just told me about flipping the direction of the inequality. So what would I do to solve this? If this were an equation, how would I think about this? Could I isolate m right away, the variable m? No, I can't because I have multiple m's. So what do I need to do first? Okay, I got to do simplify, go regular downward PEMDAS, which in this case, what would that step be? What would I do first? Yeah. Okay, get rid of the parentheses by distributing -1, right? Okay. So now one thing that sometimes people want to do here is they want to include the 3 when they distribute, but it's not. It's 3 minus the quantity. So the 3 stays out front. I'm just distributing the negative sign. What do I get? -1 is greater than or equal to 5m minus 25. Okay, so now what? I guess I could combine. 3 minus 1 is 2, right? We could do that. 2 minus 4m is greater than or equal to 5m minus 25. Whoops. Okay, now what? Okay, good. So you guys are going to, good idea. You're going to push the m's to the right side where I get a positive number. Good idea. Let's do that. So we add 4m. Now let's be a little bit tricky here. We can maybe do two things at once. Point to the direction where the variables are going to go. We're pushing them to the right. Okay. So then if we want to isolate the m, where do I probably want to push the numbers?
You want to push the numbers to the left.
That way. Okay. So how are we going to do that?
You can add 25.
There we go. Okay, so then those guys cancel, those guys cancel. And what do we get? So on the right side, we've got 9m. Our inequality stays the same. We haven't divided or multiplied by a negative. We get 27 on that side. And what's my last step? Divide by 9. There you go. And we end up with the inequality then, m on the right side, 3 on the left side. Okay, so that looks a little bit goofy. I mean, that's fine. It works. But what's another way, if I've got this inequality, technically that says 3 is greater than or equal to m. What should I probably do to that to write it in a way where I can start with a variable instead of starting with a number? So what's it going to be? Yeah, okay, I'm going to twist the whole thing around, right? Now with an equation, that's easy to do. We just take the left and the right sides and flip them. With an inequality, you just have to remember that when I twist it around, I'm also twisting around the inequality sign. Visualize it this way. You know those little microscope slides you use in biology where you think about writing the equation on one of those and then twisting it around, right? And you'd end up with the m on the left side, the 3 on the right side, and we would have twisted that symbol around so it looks like that. Okay? So there's my solution. How would I graph that then? If that's my solution, m is less than or equal to 3, I need a 3. How do I graph it? What do I do? Closed endpoint at 3, shading which way? To the left, because I'm less than. Good. Okay. Using interval notation, what would that be? Now that we got the graph, we can convert that to interval notation. What's the interval notation going to be? Negative infinity with, good, parenthesis, comma, 3 with bracket. Okay, very good. Okay, now I just want to show you one other thing here. So I could have, when we got to this step right here, I want to show you something. You guys did this the best way. But I could have done this too, right? I could have subtracted the 5m to the left side and got negative 9m and subtracted 2 and gotten that. Okay? What would my next step be? Divide by negative 9. Very good. Yeah, if I divide by a negative, that means I've got to flip the inequality around, right? And I would have gotten m is less than or equal to 3. Same way. Either way. Okay? Either way. Okay, how about this one? If we'd have to distribute first, right? Everybody agree? Okay. So if I distribute the 4, I'd get, what, 48x plus 16 is greater than, whoops. If I distribute the 16 over here, I get 48x minus 160. Okay, something weird's going to happen. What's my next step? Yeah, when I try to move the 48x's to the left or the right, it doesn't matter, whichever one I do, the x's all cancel, right? We've seen this stuff before. I end up with the result 16 is greater than negative 160. How do you think I interpret that? No solution? Everybody got a different idea? So what would it be then? Is that true or false, everybody? True. That's true. 16 is greater than negative 160. So if the variables go away and I get a true inequality, just like a true equation, what is that probably implying? All numbers will work, right? That's the math God's way of telling us. If the variables disappear, they're telling us it doesn't matter. If the variables disappear, they're telling us it doesn't matter what value you pick. If this is true, any value is going to work. It doesn't matter which one you pick, they're all going to work, right? So because it's true, it's all reals. Okay? How do I, okay, so we know it's all reals. How would I write that using interval notation? Using interval notation. Now, if I graphed it, if I graph it, what would the graph look like? How would I graph the solution all reals on the number line? What would it look like? What do you think, Juliana? 2 circles and okay, but if there's 2 circles and it stops, that would mean there's some values that wouldn't be included. Oh, there's no endpoints. Yeah, it's just everything, right? It would just look like that. It just is the entire real line because all real numbers would work. Okay, now based on that graph, how would I say that with interval notation, do you think? Infinity on the right. Negative infinity on the left with, that's it. Yeah, that's how we'd say it. That's how we say all reals with interval notation. Okay? Okay, last one. Last one, and we'll call our quits here. So look at this guy. Same kind of thing. If I'm going to zip through this so I get you guys working. I feel like I'm taking too long. So if I distribute the negative on the right side, I get 6x minus 4 on the left. On the right side, I get 3x minus 12 plus 9x. Oh, sorry, plus 3x, not 9x. Collect like terms. I get 6x minus 4 is less than or equal to 6x minus 12. Everybody agree? If I subtract the x's, both 6x's go away, right? And I get the I get the inequality, negative 4 is less than or equal to negative 12. True or false? That is false. Okay, so if it's false, how do we interpret that? Yeah, no solution. Okay, the variables went away, so it doesn't matter what you pick. It's false, so it's never going to work. Okay, good? All right, jump in. See if you can get a couple problems done to practice this.